Picture this. It is December 2012. You are in a hotel room at Harrah's Casino in Lake Tahoe.
Okay, setting the scene.
Yeah. And there is a 64-year-old academic in this room. He has a back injury that is so severe, he literally hasn't sat down since 2005.
Oh, wow. Not at all.
Not at all. Like when he eats, he kneels on a foam pad like a monk. When he travels, he has to lie completely flat across the back seat of a car.
It's an incredibly vivid, almost, bizarre scene to imagine.
Right. And right now in this hotel room, he is standing up. He's working on a laptop that is precariously balanced on an upside-down trash can at the end of the bed.
Just a makeshift standing desk.
Exactly. And from this upside-down trash can, this man is running an auction. He's selling his newly formed company, a company that has exactly 3 employees, counting himself.
And 0 products, right?
0 products. It has absolutely no plans to ever make a product. Its website is terrible and offers nothing but a name. DNN Research.
Yet, on the other end of that laptop, some of the most powerful tech titans on the planet. I mean, Google, Microsoft, and the Chinese giant Baidu. They are locked in this frantic, multi-million-dollar bidding war for this shell of a company.
A bidding war that eventually climbs to $44 million.
Yeah, it's wild.
Here's where it gets really interesting. The man standing over that trash can was Jeff Hinton. And the product he was selling was the spark that ignited the modern AI revolution.
The breakthrough in what we now call deep learning or neural networks.
Exactly. So in today's deep dive into Cade Metz's book, Genius Makers, we are tracking how a mathematical concept inspired by the human brain went from being an absolute academic joke to becoming the most powerful technology on Earth.
We're going to explore the eccentric minds who kept this idea alive in secret, how it sparked a massive corporate arms race, and the very real, immediate dangers this technology poses to us today.
Yeah, because it's everywhere now.
It really is, because to understand why that 2012 auction in Lake Tahoe was such a monumental shift, we actually have to look at the wreckage of the technology's first attempt.
Right. We have to rewind.
Yeah, back to 1958 to see why the scientific establishment considered this entire field a total failure.
Okay, so taking us back to Washington, D.C., to a man named Frank Rosenblatt. He was a psychologist from Cornell working with the U.S. Navy on something he called a perceptron.
Right.
Specifically, this massive room-sized machine called the Mark I. And to grasp why the Mark I was so radical, we had to contrast it with how computing worked at the time.
Traditional computing.
Yeah, what they called symbolic AI. It was rigid. It was about humans writing specific step-by-step code, like those expert systems of that era.
Where programmers would try to hard code knowledge.
Exactly. They try to code a doctor's medical knowledge into thousands of brittle if-then statements. Like if the patient has a temperature of 101, and if they have a cough, then prescribe this.
But the moment a patient presented a symptom that fell outside those rigid rules,
the entire system broke down. It just couldn't adapt. I think a good analogy here is baking. Traditional symbolic AI is like giving a computer a strict recipe to bake a cake.
Okay, yeah.
But neural networks are like giving a computer the ingredients and letting it ruin 100 cakes until it figures out the recipe completely on its own.
That's a great way to put it. Rosenblatt's Perceptron was designed to bypass that exact limitation. It was based on a concept called connectionism.
Connectionism, okay.
Right. Instead of top-down rules, it was modeled loosely on the web of neurons in the human brain. I wasn't just lines of code. It was a 5-ton physical beast of a machine.
5 tons.
Yeah, filled with banks of mechanical potentiometers and electric motors. They would hold up cardboard squares with letters printed on them to a crude 20 by 20 grid of light sensors serving as a camera.
So it's looking at an A or a B, and instead of following a rule book, it's just guessing.
Exactly. It throws out an answer, gets it wrong, and then physically adjusts those motors and dials, altering its internal mathematical weights, and tries again.
It ruins 1,000 guesses until it figures out the pattern on its own.
Precisely. It learned purely from exposure to data. And when it finally learned to recognize the letters, the press went absolutely wild.
I can imagine.
The New York Times essentially called it a Frankenstein monster that thinks. They published these breathless articles claiming this machine would eventually walk, talk, and reproduce itself.
Okay, the hype was out of control. But let me stop you there. Because the historical record shows that almost immediately after this massive press tour, the entire scientific community completely turned against the concept.
They really did.
If connectionism worked, and it was successfully mimicking the brain to learn on its own, what went wrong? Why did the scientific community turn against it?
Well, the scientific establishment fought back, largely led by a prominent AI pioneer from MIT named Marvin Minsky.
Okay, Minsky.
Minsky and a colleague published a rigorous book that systematically took apart the perceptron. They proved it had a fatal mathematical flaw.
What was the flaw?
Sure, it could recognize a printed letter A after enough tries. But Minsky showed that the underlying math couldn't even solve a basic logic puzzle called the exclusive or problem.
Meaning the machine couldn't answer a simple comparative question.
Right. If you showed it 2 dots, it could compute if they were both black or if they were both white, but it couldn't compute the concept of different.
So it couldn't grasp that one was black while the other was white.
Exactly. It hit a hard computational wall. It was a fundamental limitation of the algorithm. And if we connect this to the bigger picture, Minsky's critique wasn't just an academic debate, it was an execution.
Wow.
It literally froze government funding for neural networks for 15 years.
15 years.
Yeah, it ushered in what researchers call the first AI winter. The entire field abandoned the brain-mimicking idea, dismissed connectionism as a dead end, and went back to writing strict, step-by-step, symbolic AI rules.
It is wild to think that technology shaping the entire infrastructure of our modern world was functionally dead in the 60s.
Completely dead.
Because the establishment completely abandoned it, the idea was forced underground. It only survived because a stubbornly eccentric group of academics nurtured it in secret, refusing to let the math go.
Which brings us back to Jeff Hinnon.
The man standing over the trash can.
That's him. Back in the 70s and 80s, he wasn't a wealthy tech founder being courted by billionaires. He was a British eccentric who had dropped out of physics, failed at psychology, and spent time working as a carpenter in London.
But he was deeply obsessed with how the human brain processed information.
Deeply. Even when Marvin Minsky and the titans of the AI world actively ignored his papers and told him neural networks were a laughable waste of time, Hinton kept tinkering in the academic wilderness.
And he eventually ended up in the U.S., collaborating with researchers who shared his unorthodox views, including a psychologist named David Rumelhart.
Right. And together, they achieved the massive breakthrough that revived the field. They solved Minsky's fatal flaw with a mathematical concept called backpropagation.
Okay, let's unpack this, because this is the engine of the modern world. How exactly did they fix Rosenblatt's mathematical wall?
It came down to 2 crucial fixes in how the system processes its learning. First, it was how the system started. Rosenblatt's original Perceptron started all of its neural weights.
The numbers determining how important a piece of data is.
Exactly. It started all those weights at 0. But if everything starts at 0, the math naturally wants to keep everything equal. The system couldn't prioritize conflicting data. In mathematical terms, it couldn't break symmetry.
Ah, like a giant tug-of-war where everyone on both sides is pulling with the exact same zero force.
That's a great visual.
Yeah, it's a total deadlock. Nothing happens. No ground is gained. No patterns are discovered.
Right. So Rumelhart made a shockingly simple suggestion to Hinton to break that symmetry. What if, instead of starting at 0, we start all the weights at random numbers?
So going back to the tug-of-war, it's like everyone suddenly starts with a random asymmetrical grip and a totally different stance.
Yeah.
It's chaotic at first. Some are pulling hard, some are slipping. But because the forces are immediately unequal, the system can eventually find a winning rhythm. The deadlock is broken.
That is the first half of the solution. But the real magic is the backward part of backpropagation.
Okay.
When the network makes a guess, say, it looks at an image and wrongly guesses it's a car instead of a truck. It calculates exactly how wrong it was. It quantifies the mathematical error.
Right.
Then it takes that error signal and sends it backward through the multiple layers of the network. It tweaks each of those random bricks slightly, penalizing the connections that led to the wrong answer and rewarding the connections that pointed toward the truth.
So it's continuous mathematical feedback loop. It's like a sports team meticulously reviewing game tape after a loss.
Exactly.
The coach traces the final missed shot backward, figuring out which pass was slightly off, which block was missed, and adjusts everyone's behavior for the next play. Every single mistake makes the system incrementally smarter.
And this feedback loop allowed neural networks to solve the exclusive or problem. They could handle profound complexity. And they proved it in the real world in 1987 with a project called LVN.
LVN.
Yeah. A first-year PhD student named Dean Pomerleau used Hinton's backpropagation math to teach a bulky royal blue Chevy ambulance to drive itself.
Without human written rules?
Zero human rules. No human coded the rules of the road. No one programmed what a stop sign was or how to steer. The system just watched humans drive.
Wow.
It analyzed the visual data from a bulky camera mounted on the roof, calculated its errors, passed them backward to adjust its random weights, and learned. It eventually navigated a park in Pittsburgh entirely on its own, hitting 60 miles per hour.
60 miles per hour in 1987. That's incredible. But LVN proved the math worked flawlessly, right? The breakthrough was real.
It was real. But the project also revealed a massive physical bottleneck.
The hardware.
Yeah. To process visual data from a camera, the computer taking up the back of that ambulance had to be the size of a refrigerator. And it still ran at a fraction of the speed of today's smartwatches.
Right. The computers of the 80s and 90s were just physically incapable of processing the massive amounts of data these neural networks needed to truly become intelligent.
The theory was brilliant, but the silicon couldn't keep up. The math basically had to sit on a shelf for another 2 decades until the video game industry inadvertently saved artificial intelligence.
Video games.
Yeah. It wasn't until the invention of fast, powerful processing chips designed to render millions of pixels for gaming that computers could finally handle the massive parallel calculations required by backpropagation.
So once the hardware caught up to Hinton's math, the tech industry ignited, which is exactly why we find ourselves back in that Lake Tahoe hotel room in 2012.
Precisely. The corporate titans getting in that auction weren't buying a software package. They were bidding on the realization that Hinton's decades-old math was suddenly the most valuable algorithm on Earth.
And the auction was frantic. Baidu started the bidding at $12 million. Google and Microsoft instantly jumped in.
DeepMind, too, which was just a tiny startup at the time. They desperately tried to bid using company shares but had to drop out because the big players were throwing around mass amounts of cash.
And the imagery of this corporate war is just hilarious. You have these multi-billion-dollar companies bidding over Gmail threads, fundamentally altering the trajectory of the tech industry. Meanwhile, Hinton is terrified of getting sick from the dry mountain air in Tahoe.
Oh yeah, his humidifier setup.
It's amazing.
Yeah.
He takes the mattress off the sofa, puts it on the floor, sets up an ironing board between the beds, and drapes soaking wet towels over it to create a makeshift humidifier tent to sleep in.
He is completely absurd.
And it gets better.
Yeah.
Kai Yu, the executive from Baidu, keeps knocking on the hotel room door to check in on the negotiations. Every single time he knocks, Hinton scrambles in a panic, making his 2 grad student employees hide the mattress, the ironing board, and the wet towels.
He tells them, this is what vice presidents do.
Yeah, he didn't want the buyers thinking they were investing $30 million in a guy who was frail and eccentric.
What's fascinating here is how the auction actually ended. The price was skyrocketing. $35 million,
Yeah.
$40 million, $44 million. The momentum was entirely in Hinton's favor and
just
stopped it. He just stopped it.
The bid is at $44 million. The giants are in absolute frenzy, and he just pulls the plug.
Mm.
That doesn't sound like a shrewd Silicon Valley CEO holding out for maximum profit. That sounds like an academic who's suddenly got spooked by the corporate machine.
Well, he and his students were academics at heart. They weren't ruthless entrepreneurs. He stopped the auction at $44 million because he decided he simply wanted to work at Google.
You just picked them.
Yeah, he felt it was the right intellectual home for their research. He literally emailed the other bidders, thanked them for their time, and shut the whole thing down.
Which set off an absolute panic among Google's rivals.
Mm.
Suddenly, everyone realized that deep learning wasn't an academic curiosity anymore. It was the ultimate corporate prize. Mark Zuckerberg is described pacing around a hotel suite in his stocking feet, desperately trying to recruit any AI talent he could find for Facebook. Because if you didn't have deep learning, you were going to be left behind.
And that corporate weaponization of deep learning changed everything. Once big tech got their hands on this, they scaled it up to a level that Frank Rosenblatt couldn't have dreamed of in 1958.
Yeah, the massive scale.
But as they deployed these massive neural networks across the world, the sheer scale of the technology started to reveal massive, terrifying structural flaws.
Right. Once the tech was real and everywhere, the tone shifted from excitement to existential dread. You started hearing this intense sci-fi fear echoing through Silicon Valley.
The doomsday scenarios.
Exactly. Elon Musk goes on television and actively compares artificial intelligence to nuclear weapons.
Nick Bostrom, an Oxford philosopher, popularizes this thought experiment called the paperclip maximizer.
Oh, that one. The hypothetical scenario where you give a superintelligent AI a simple goal, like make as many paper clips as possible.
The fear is that the machine might decide humans are made of atoms that could be better used for paper clips, and it just efficiently destroys humanity to harvest our resources.
But I really have to push back on this sci-fi doom scenario.
Mm-hmm.
Are we really worried about Terminators? Or are there actual real-world problems happening right now? We have billionaires sitting around debating hypothetical Terminators turning humanity into office supplies while completely ignoring the actual tangible damage this technology is doing today.
I agree completely. And a whole new wave of researchers stepped up to force the conversation back to that immediate reality.
Thank goodness.
Yeah, researchers like Timnit Gebru, Joy Buolamwini, and Meg Mitchell. Mitchell famously pointed out that the AI field suffers from a severe sea of dudes problem.
Sea of dudes.
Yes. The people designing, training, and building this world-altering technology were almost entirely white men.
Which creates staggering blind spots. Joy Buolamwini's research with facial recognition is terrifying. She was testing massive, commercially available systems from giants like IBM and Microsoft.
And what did she find?
She found that while the systems were almost perfectly accurate at recognizing white men, they had an error rate of up to 35% when looking at darker-skinned women.
Wow.
35%. The machine fundamentally could not see them accurately.
This raises an important question. If an algorithm is purely mathematical, how does it become racist or sexist? Does it have a conscious bias?
It's the connectionism. It's the data. Neural networks don't have human-written rules to fall back on. They learn purely by looking at what we feed them.
Right.
If you feed a neural network a training data set of faces that is overwhelmingly filled with white men.
It becomes incredibly exceptional at recognizing white men and fails at everything else.
Exactly.
The machine doesn't have an independent moral compass to filter out our flaws. It absorbs our history, encodes those biases directly into its mathematical weights, and then amplifies them at an unprecedented scale.
Scary.
It is. If you use historical data to train an AI on who should get a mortgage or who is mathematically likely to commit a crime, the algorithm learns all the racist and sexist patterns baked into that human history as rules for future success.
So what does this all mean? Let's take a step back and look at the sheer scale of this journey. We trace this arc from a 5-ton machine in 1958, physically whirring and clanking as it learned to read cardboard letters,
to an academic winter where the concept was basically considered contraband.
Yeah, through the stubborn persistence of researchers who figured out how to backpropagate errors, waiting decades for gaming hardware to finally catch up to their theories.
To a frantic billionaire arms race that embedded this exact math into the invisible fabric of our daily lives.
Exactly. Every time you use a search engine, or your phone recognizes your voice, or you apply for a loan, you are interacting with backpropagation. You are interacting with the ghosts of Frank Rosenblatt and Jeff Hinton's research.
And the most crucial thing to remember is that these systems are not intelligent in a human sense. They don't understand nuance, context, or morality. They are vastly powerful pattern recognition engines holding a mirror up to the data we generate.
Which leaves us with a totally different kind of existential question to ponder. We spent all this time, spanning decades, forcing machines to mimic the architecture of the human brain. But as these neural networks get deeper, adding billions and billions of parameters, even their creators like Jeff Hinton admit they no longer truly understand exactly how the AI is arriving at its answers inside that black box.
It's a sobering thought.
It really is. If these deep learning systems learn entirely by observing human data, and they are now being deployed to diagnose diseases, approve mortgages, and drive cars, are we actually programming machines, or are we just raising them like